My name is Nikolay. I'm CTO of the Color project and text data tech company. And today I would like to give you some technical insights into 컬러플랫폼 and technologies that we have behind it. So 컬러플랫폼 is the next paradigm crypto platform, and it will be the first hardware-empowered blockchain. Let's guess. What do you think is the major blockchain challenge? Maybe number of transactions per second, or consensus, or BFT, or storage size? From our point of view, the major blockchain challenge is number of people that use it day by day. You see, nowadays, the number of user base is growing very fast, starting from first 50 million user or passenger was driven by air company 68 after starting commercial services to 2 years of 50 million users of Twitter. Let's see how blockchains deal with that. Actually, we can say that blockchain, after 10 years of operations, gained 500 users, active wallets per month. Ethereum have something comparable, but what are those wallets? Let's see. The gambling application that run on top of blockchains can gain up to 500 active users per day. Finance application can give similar results. Even CryptoKitties that made an upsurge in earlier this year now have about 500-600 users per day. So we can see that out of these 500,000 users, the actual people using the blockchain for their returns is counted by maybe 1,000, 2,000, up to 10,000. So people actually don't use blockchain in their day-to-day life. And how to establish massive growth of users of EAPs of transactions. The one who will be able to do this will become a top tier market cap will gain the top tier market cap. So let's have a look at the existing evolution of blockchains, starting from Bitcoin that become just money transfer between anonymous counterparts. Second generation Ethereum that provided a new feature called smart contracts and code execution and distributed apps and so on, decentralized apps. Next level is EOS, Cardano, Tezos, who implement new proof of stakes and trying to establish new governance models at the blockchain. And the 컬러플랫폼 is different from them all. We are a kind of a next paradigm in blockchains. We have semiconductor-powered blockchain. We have cloud-based platform. We are targeting building a powerful ecosystem for people. So one of the key features of modern blockchain is that they pretend to be a global single computing facility, like many nodes connected to the network, contributing their power to the community. But the truth is that actually the performance of the network is limited only to very small extent, that is maybe to one block build at a time. So what do I mean? When a client wants something to be executed in the network, they file from their terminal node a transaction to some pool that keeps not yet executed transaction. Then this transaction is extracted by block builder or orderer or miner, whichever name you call it, and is inserted into a block. During this operation, if it is a smart contract, block builder executes this transaction. Then the transaction goes for validation. Executed once again to update the state of the validator, to check correctness of execution performed by the block builder. What does it mean from the practical point of view? It means that while a block is being built, all other nodes wait for its results. There is actually no concurrency in this architecture. Transactions are executed one by one, no concurrency, strict sequential order, and despite the fact that there could be lots of other nodes, maybe thousands of them, the all power of the network is limited just to one computer, the one that builds the block. So this is the metaphor in this picture, like this small frame where everyone wants to get in. So real blockchain architecture needs lots of enhancements to become usable for real life applications. And in 컬러플랫폼, we expect 3 quantum jumps from the current state of the art to the next paradigm, next shift of technologies in blockchain. They are semiconductors involved in the operations I will tell you about a little bit later. There is a 2-tier architecture using cloud paradigm, and this is a new approach to building ecosystems. So what is semiconductor-empowered blockchain? In Kala, we use a feature called PUF, or PUF. This is physically unclonable function. Physical unclonable function is like a fingerprint that could not be imitated, cannot be hacked, cannot be decoded by third-party attackers. PUF is a result of a manufacturing process at semiconductor factory when some unavoidable irregularities in production process results in a unique structure of gates on some array. Some gates could be closed, some gates could be open, and this distribution of holes is unique for every dice, every chip. And this uniqueness can be considered as a private key that is hardware emulated, that is hardware implemented, that has no viable approach to clone. No one without an electronic microscope can decode and read this private key. It is very highly secure hardware system. And in Kala, we're using a chip with a PUF crypto engine that uses PUF as a private key. So one of the major problems with hardware wallets is how to save data that is kept inside. One approach is to provide so-called obfuscated chips where the major path is obfuscated by thousands, or at least hundreds, other paths that are extra. They have no functionality, but they hide the major path or the major data storage in the system. Instead of that, in our approach, we are using a chip with a crypto engine built inside. That means that every data, the data is actually stored in some onboard flash memory. But what is stored inside? Actually, what we have here is some encryption module that takes the data coming from the outside, some byte stream, and it stores to the flash encrypted data. The key of encryption is unique path fingerprint that is not visible from the outside. We have such an encryption algorithm with elliptic curves on 256 bits elliptic curve with 256 bits. And this makes this efficient and very resilient to attacks, even to physical analysis, because first you need to guess what is the path private key, then you have to read the data, then you have to decode the data if you are an attacker. So this is a very safe feature. It also has a random number generator and unique ID based on path. So what is the purpose to have it as part of the system? You know, when actually people try to tell you that you have a peer-to-peer money, like Bitcoin was originally called as the first peer-to-peer money system, this is actually not true. When you try to communicate with another peer, just maybe I would apply one phone to another phone and it will make transaction. The truth is that it is not peer-to-peer. The transaction should go somewhere to the server, to blockchain, to be validated, to be burned in, and then confirmed. Actually, this is much better than traditional banking, where there is a complex system of trust. When you trust your terminal device, you trust your card issuing bank, you trust the procedures in the bank, you trust the protocol, you trust the other side of the bank, you trust everybody in this scenario. So using blockchain reduces amount of trust to some reasonable amount. But in our approach, we go even further. We go to the metaphor of real coin. What is the difference between real coin and, I don't know, credit card? In real coin, when you give the coin, you don't own the coin anymore, and the other side, your partner, becomes the owner of this coin. And you don't need any bank, you don't need any intermediate, you don't need any license to give out the coin. Compare it with even with blockchain. To give out a Bitcoin, you need actually to file a transaction. It goes through a huge farm that builds blockchain, and only after that you receive confirmation that your Bitcoin was passed to another person. In our approach, in Color, we are introducing a new concept of Color Pay. That would be a wireless NFC connected or maybe Bluetooth connected device, maybe this size like a credit card, with a chip on board, with communication channel on board, that could be used for payment, true payment peer-to-peer, without any third party. So when somebody originates the transaction, they make such transaction like sending money, encode it or digitally sign it in the PubSecure area using the private key that we have here. Send the encryption transaction to another hardware wallet. The hardware wallet receives it, processes it in the private part of the chip. If everything is okay, the other side, for instance, confirms the transaction. This side decreases the money, decreases the balance. This side increases the balance. So everything goes really one-to-one. No third parties. So just two chips communicate to each other. They update their balances correspondingly, and this is actually what we call money. Money is, well, not money, coin. Coin. is something that you give to another person without any intermediate. And this is a true revolution in electronic currencies, because nobody actually have such level of trust. Not in fiat world, not in cryptocurrency world. So Color is the first one to be in semiconductor empowered blockchain with our coin to be really transferable as a real coin, as a one-to-one peer-to-peer transaction kind. And the second feature of our platform is use of cloud. Original concept of blockchain was that blockchain will eliminate clouds. No need for clouds, because actually blockchain is a fog of computers that could execute, but this is actually not true. As I already said, in the fog of huge and powerful computers that support a blockchain, actually only one computer at a time can compute only one transaction at a time, one by one. So this is not what cloud is, when lots of computations run in parallel. So what is, once again, the situation? Transaction data from terminal nodes goes to blockchain, and only one node at a time can compute it in one block. This happened in Bitcoin, this happens in Ethereum, even new advanced platform EOS that claimed to introduce cryptocurrency to be concurrent is still single-threaded. They claimed, but not yet implemented, multi-thread execution. In our approach, we introduce between the blockchain level and terminal nodes a new layer that is called logic runners. Logic runner is actually a cloud, a container in the cloud that executes the code of the app. Why do we use cloud? The actual reason is that what is decentralized application means? Decentralized means that nobody, neither developer, no user, knows where the application actually runs. This prevents from code injection, this prevents from some alteration of text that could happen if the evil side will know where the application runs. But since the application runs somewhere in the blockchain, then this is called decentralized app. And we want, of course, to keep this idea of decentralization in 컬러플랫폼 as well. But in our sense, we would like to both combine decentralized applications and concurrent execution. Not like in blockchain when you have all executed one by one, but true concurrency when hundreds or thousands of the apps can run simultaneously. And to do this, we said we'll use the well-known and technologically proven concept of a cloud. A cloud is actually an environment when applications are distributed in some environment using containers, and they are not connected to the hardware. They can migrate from one hardware to another hardware. They can be launched in different real hardware machines. They can even be launched in parallel to produce different results. So in our approach, we use a cloud that serves in the logic runners lots of code of the apps. Terminal nodes like smartphones communicate with such service nodes through secure transport. And this architecture provides efficient execution of business logic. We have a proof of stake-based consensus for blockchain and storage. And what's very important for deployment of the apps is that to create the app, developers don't even need to learn some cryptic languages like Solidity or Roland or different other languages that were implemented for blockchains, or you can use like in Neo C#, but there is very limited variation of C# that it has its own private virtual machine, and who knows what kind of defects it can have inside. In our approach, here, at the level of logic runners, you can use whichever language you want. It could be PHP, Python, Java, JavaScript, C++, whichever you want, whichever is convenient to you. And it will immensely simplify development of the apps. Because besides of the language, you gain lots of tools for development, like integrated development environment, debugger, testing tool. That's all is very important to create good software. And distribution between code execution and data storage is very important for building the ecosystem of color, for introducing the economy, for introducing the coin. We decouple data from code to establish a new level of trust and a new level of visibility for both clouds and blockchain. So the idea is that inside of a service node, code communicates with a storage, with a state DB that keeps persistent values, that keeps such constant, such values like balance, like assets, like ownership, that should be persistent between invocation to invocation. And distributed ledger is a blockchain that is used to update this database across the platform. So we can have multiple hosting infrastructures, we can have multiple databases inside. They all need to be synchronized. What is the challenge here? The major problem that is well known for computer science is called data race. Consider a simple example. For instance, we have several wallets like Alice, Bob, and Charlie. We have several infrastructures. Each of them has its own execution environment. And in one of the environments, Alice files a transaction. She wants to transfer +5 to, let it be +10. +10 to Bob. In another infrastructure, Charlie files a transaction when he wants to send 5 coins to Alice. What is the result of these two transactions? If the balance of Alice, consider the original balance of Alice is 7 color coins. What is the resulting balance? The true answer is that there could be 2 different outputs. In one scenario, we had 7 coins with Alice. Then she tries to send 10 coins to Bob, but this is impossible. She doesn't have enough money, and therefore her transaction would be rejected. Her balance is left as 7. Then Charlie arrives with his 5 coins, and the resulting is 12. Okay? What is another approach? Another scenario. In another scenario, we start with the same 7 coins that Alice originally had. Then she receives 10 coins. 5 coins from Charlie, and has now 12. After that, she sends 10 coins to Bob, and she got 2. Charlie has Charlie loses 5, and Bob receives 10. How to guess which scenario is right? This is not important. Both are right. What we really need to ensure is that both databases, or not both, maybe all 3, all 5, all 10, all 100 databases, have the same value, either 12 or 2. This is called synchronization problem. And this problem is very tough. When you have databases on different sides of the globe, the time to travel of the information could be measured by hundreds of milliseconds. And this is rather slow. So in our approach, we are going to use blockchain as such a tool that ensures that every state DB has the same values. If we have 2 here, and on the balance of LS, then balance of LS here is also 2. If it is 12, then it is 12. Everywhere it is 12. So the key point is how to ensure that. And we introduce blockchain as such a synchronization tool for write transaction. When an application in the app wants to write something to the database, update it, then synchronization starts. But the truth is that maybe 90% of such requests, they are really very fast and efficient. So Color VM makes the best of 2 worlds. Not VM, Color project. Efficient and developer-friendly environment for development, and reliable synchronization protocol in blockchain. So in our containers, we will provide libraries and APIs to connect to database, connect to storage, connect to blockchain, can work with terminal node, some cryptography services, and communication services. And in blockchain, we will have an advanced protocol of consensus based on Tendermint. In order to make it faster, maybe the most long part of the consensus is not actually the consensus itself, but for sending out the block to be confirmed to all the parties. So why we introduced here a number of leagues? Actually, the challenge is like this. Consider we have, 49 nodes in the network. And we have one block producer that wants to send this out to confirm the block. He has to send 49 megabytes in one burst to all those nodes to make sure that they all have the copy of the block to do consensus. This is the really longest part of the protocol. So in our approach, we are splitting this into 7 regions. So the original node has to send only 7 messages, while the nodes in leagues will send it to partners for validation. So instead of sending 49 one by one from the block producer, we send burst of 7, and then in parallel they will send it forward. So we accept that the time of the protocol, of the synchronization protocol, will be about 0.5 seconds, and we are going to use Tendermint-based consensus. But this all is about technology. So what is about users? Let's see how modern blockchains evolve. First, they spend a lot of efforts to create the technology core. That's okay, that's right. Without technology, it doesn't run. But then they say, come to us, build your apps with us, use our infrastructure. What is the result? The result is that, for instance, in the EOS network, if you open a monitor, you can see that most of the blocks have 1 or even 0 transactions. They don't have enough users, enough BAPs to load the system. The system is almost empty. In our platform, we are starting with lots of applications for users, like lot application, like wallet application, like rewarding program, like design application, like blogging platform, and so on, that could people use even before the platform is started. And after Color platform is launched, they will be transferred to Color Spectrum Technologies as the backend to keep the data, to keep the money flow, to hold the transactions. So we believe this is the only way to really make exponential growth of user base, to attract people, so that the platform is not working for itself like EOS, that actually producing empty blocks. If we want to have real life, we need to provide real apps that are usable, that are interesting, that people could profit from. And this is the third key point of our platform. So first, build user base, and only then, so maybe building user base even before finalizing the core of the platform. Okay. And then the tree of applications will grow even faster. So the Color Spectrum technology and corresponding development kits with the tools like hardware, wallets, and offline transactions will blossom in the future and give birth to lots of applications for users, for real economy, for real coin flow, ideas flow, and for blossoming and flourishing for the society. So thank you very much. Think Color.